Hi, in today's video we'll talk about how to make gaming on Linux work the best, especially on Wayland. Now, Linux gaming has come a long way and it's better than ever, with recent additions like HDR and variable refresh rate, though VRR or variable refresh rate has been supported for a while now. Gaming on Linux is smoother and more polished than ever. But some games, especially indie games or older games, can strain your GPU too much or be poorly optimized, leading to stuttering or inconsistent frame delivery. There are AAA titles that have VSync that's just horrible, like Cyberpunk for example, which is known. Now that's where triple buffering comes in. If your monitor doesn't support VRR, is a lifesaver. Triple buffering is lifesaver for games where low latency isn't critical, helping smooth out frame delivery. Let's take The Long Drive, another game that has issues, as an example. It stutters horribly on Linux when the GPU is capped. Without triple buffering, meanwhile, an example, Genshin Impact for kiddos out there, another Unity game, doesn't have these issues. They probably optimized it better, or is lighter game overall for my RX 6600. We will basically split video in two parts. First part for people that monitor doesn't support VRR, and second part for people that have monitors that does support VRR, variable refresh rate. Now, these tips might not apply to Windows, of course, where on Windows probably games will behave differently. And also you have tools like AMD Adrenalin or Nvidia control panel on Windows. On Linux, the graphics stack is tightly integrated, almost like Mac, giving you multiple layers to enable triple buffering in. The first layer, for example, you can enable it in DXVK. If your game is a Windows game using compatibility layer like Proton, you are using also DXVK, the DirectX to Vulkan translation. Game scope also is one where you can enable triple buffering, it's one more layer. No, game scope you necessarily don't need to use it, more on that later also. Or you can use triple buffering at your desktop compositor, which lots of compositors has enabled by default, of course for non-full screen apps. For example, KDE has it and GNOME gotten it lately. Hyprland is disabled the triple buffering by default. It has feature to enable it and it's still in development. Now, in this video I will show you how to enable triple buffering at the DXVK level and tweak your compositor settings for optimal performance. First of all, do not use GameScope. Yeah, I find out that GameScope actually worsens the frame times somehow, at least on my system. Now use it unless you really need. By my testing I found out that GameScope adds unneeded stutter in some games, and if you are using VRR it messes with it in some games. When to use triple buffering? Now basically when your display doesn't support VRR and you are relying on VSync for smooth tear-free experience. Triple buffering adds extra frame buffer to smooth out frame delivery, reducing stuttering at cost of slightly higher latency, about 6.9 milliseconds on a 144Hz monitor. Use it for games running at high FPSs, where added latency is negligible, even in latency sensitive titles, so higher the refresh rate higher the FPS of a game, lower the latency will be added with triple buffering. Use it also in games where latency isn't critical, and games that internal VSync implementation sucks. Unless you wanna play without VSync, that's your choice, then you will have screen tearing or stuttering. For games that their VSync doesn't suck, you can use default double buffering and leave out triple buffering option. If you need triple buffering, it is the best to enable it at DXVK level. You can enable it with export dxvk config equals double quotes dxgi.num back buffers equals 3. You can also set that as an environment variable, but then everything will use it. Setting up desktop compositor. Now this is an important one. This is how you set up your DE or your compositor. Before enabling triple buffering or VRR, optimize your desktop compositor. I use Hyprland, a Wayland compositor, which is frame perfect and prevents screen tearing by default. Here's how to set it up. Enable direct scanout. This is an important one. Direct scanout sends game frames directly to the display, reducing latency 1 to 3 milliseconds. In Hyprland conf, for example, I can set render direct scanout equals 2. That means the direct scanout, it will apply to games. It's content type game. So how to add that? For example, you can add window rules that add content type game to game scope, or for example to Steam apps. You can use in Hyprland the regex, regular expressions, and make Steam apps which classes always start with Steam_app. Now another thing is make sure your desktop has disabled triple buffering. Now for at least desktop, triple buffering you can have enabled, but when full screen apps like games, triple buffering should be disabled. In Hyprland it is disabled by default, and you can enable it with new render scheduling setting to true. Is not recommended for now, and most likely needs further implementation, so is not enabled always in games. Of course, triple buffering can basically conflict with triple buffering set at the DXVK level. Although normal triple buffering can be used also as triple buffering for a game when needed, it's just better to set it at DXVK. Now VSync, another important one. Turn off Hyprland's VSync for games. Basically set allow tearing to true. Under general, that should suffice for full screen games. To make sure all games don't use Hyprland's VSync, do something like window rule equals immediate. You can force immediate output frames. You can still use games internals VSync despite having immediate. That means even if you use VSync in-game, you don't want double VSync. No, I'm not 100% sure VSync can be double. Maybe it turns off when it sees game has VSync. But still, for VRR, of course, VSync should be generally off. Of course, Hyprland already automatically turns it off for VRR gaming, which is to be expected. Set up VRR, this is the next thing. Turn on VRR for monitor that supports it. In Hyprland, for example, I just add VRR to monitor config, and that's set to 3. 3 means for games and videos, the content type, and with upper optimizations together, that should work nicely. Of course, turn off in-game VSync to fully utilize VRR. If you see your VRR refresh rate in your monitor settings jumping to values that are 2 times higher than the game FPS, it's usually okay and not a problem, since your game might have too small of a FPS for your monitor, and frame duplication or LFC low frame compensation is used so the monitor can show low frame rates, lower than it's able to show. You can test my theories with VRR tester or the VRR test from Nixula on GitHub and check if your VRR is working right.